Let's talk about a pretty dramatic breakthrough in the battle against antibiotic resistance. It's an incredible story, really, about a discovery that was hiding in plain sight for more than 50 years, and it just might be the new weapon we desperately need.
You know, the stakes here could not be higher. For decades, we've basically been watching bacteria evolve in real time, outsmarting our best drugs one after another. But this discovery we're about to dive into, it's a genuine light in the darkness. It really feels like a potential turning point in this global health crisis.
So, to really understand why this news is so incredibly exciting, we first have to get a handle on the sheer scale of the threat we're up against. What exactly is a superbug anyway, and why have they become such a massive danger? Okay, so what is a superbug? Well, it's not some new kind of monster from a sci-fi movie. It's usually a bacterium we already know, like Staphylococcus aureus, that is just, well, it's learned to survive our medicines. And the most infamous example of this, the one you've probably heard of, is MRSA. And this is not a new problem. Not at all. MRSA was first identified way back in 1961. That was just 1 year after the antibiotic it's named for, methicillin, was introduced. This has been a slow-motion arms race for over 60 years, and for a long time, we've been losing ground. And the cost of losing that ground is measured in lives. An in-depth report found that in 2019 alone, MRSA was responsible for over 100,000 deaths around the world. And remember, that's just one superbug in 1 year.
And when we zoom out to look at the whole picture, what's called antimicrobial resistance, or AMR, the forecast is, frankly, terrifying. If we don't find new solutions, it's projected that by 2050, superbugs could cause 10 million deaths every single year. I mean, to put that into perspective, that's more people than currently die from cancer.
So yeah, it's a bleak picture, but this is where our story takes a sharp turn for the better, because the solution might have been waiting for us this entire time in one of the most well-studied organisms on the entire planet. This timeline just kind of blows my mind. Scientists have been studying this common soil bacterium, Streptomyces colicolor, since the 1950s. Then, around 1975, they found it produced a pretty mild antibiotic. And for almost 50 years, that was that. End of story. Until now, when a new team of researchers decided to look not just at the final product, but at the recipe itself. As one of the researchers, Dr. Alona Alkalev, said, finding this was a complete surprise. It's kind of like finding a secret room in the house you grew up in. The potential was right there the whole time, just waiting for someone to notice. So, what did they find? They found a molecule that's actually just an in-between step in making the antibiotic they already knew about. Think of it like this. For decades, everyone was focused on the finished loaf of bread, which was okay, but not great. Nobody ever thought to test the power of the sourdough starter itself. And when they finally did test that starter, whoa, the results were just astonishing. It turns out this overlooked little ingredient is an incredibly powerful new weapon in our arsenal. Get this. This is the key number. The hidden molecule, that intermediate step, turned out to be over 100 times more potent against a whole range of superbugs than the final antibiotic everyone had known about for years. 100 times. And it's not just powerful, it's effective against exactly the right targets. It works incredibly well against major threats like MRSA, and another nasty one called VRE, which the World Health Organization has flagged as a high priority danger. But as incredible as that 100 times potency is, it's actually not the most groundbreaking part of this discovery. So what is? The answer is zero. In lab tests, even under conditions where other bacteria quickly learn how to resist our best drugs, scientists have so far found zero signs of bacteria developing resistance to this new molecule. Zero. And that is the real game changer. Our current last resort antibiotics, drugs like vancomycin, are failing more and more. So to find a new compound that not only kills these superbugs, but also seems to be immune to their ability to develop resistance, well, that is the breakthrough we have been so desperately hoping for. Okay, so this is all fantastic news, but a discovery in a petri dish is one thing, and a medicine that a doctor can prescribe is another. So what does the road ahead actually look like? Well, here's the plan. First off, and this is a huge deal, a team has already figured out how to make this stuff in large quantities. That's often a major roadblock that stops great discoveries. The next big step is all the preclinical testing to make sure it's safe and effective. But beyond just this one drug, the third and maybe most important step is to use this same method to look for other hidden gems. Because the big takeaway here is that this is so much more than just one potential new antibiotic. It's a whole new strategy. It's a new way of looking at nature's chemical factories and testing all the ingredients along the assembly line, not just the finished product. And that really leads us to the final, crucial question, doesn't it? For 50 years, this powerful molecule was just sitting there, totally overlooked in one of the most studied bacteria in the world. It really makes you wonder, how many other life-saving, game-changing medicines are out there right now, not in some exotic jungle, but hiding in plain sight, just waiting for us to look at an old problem in a completely new way?